to be a factoring pre-notes. And this is for you to solve or to work on as practice before you start doing factoring. Let me go ahead and share the notes with you. Remember that all of these you can find in Schoology in the file for notes or video notes for these. And then you can actually print out your notes or get the blank paper from me in class and do them as you view the video. All right, so factoring pre-notes, it's something you probably already learned. I hope you learned this already. This is taking out a GCF out of expression. So remember that the inverse of multiplying polynomials, or FOIL, is factoring. So when you factor, you're actually undoing a product. For example, if I told you factor the number 12, you could say 6 and 2, you could say 3 and 4. So basically factoring is undoing something through products. If you multiply, you would get the original number back. So the first three examples are determining the greatest common factor, or GCF, for just regular constants, for numbers. So in example 1, you have the numbers 15, 24, and 27, and you want to find the GCF for those numbers. So let me go ahead and get that pen ready for you. So for the number 15, so the way you find this is, for the number 15, you have all of the factors of 15. 1 times 15, 3 times 5, and that's where it ends, right? For the number 24, you have 1 times 24. So all we're doing is we're listing all of the sets of or pairs of numbers that multiply give you the number you have, or the number you have as a sample to find factors. 2 times 12, 3 times 8, and 4 times 6. Not 46, let me put a comma in there. And then for the number 27, it's going to be 1 times 27 and 3 times 9. And all we have to do to find the GCF for those three numbers is find the biggest number that is in common in all three. So if you look at the list for 15, the list for 24, and the list for 27, the biggest number they all have in common is 3. So your GCF here is 3. That's it. So that's pretty much it. This is just when you have numbers, no variables, no powers, nothing like that. So for ST1, pause the video is what I mean. Do it on your own and then come back and play the video to make sure you got it. But the next three numbers will be 18. And I have a thing where I have to list these things in order. So I have 18, I have 42, and I have 66. Remember, you got to find all of the factors, and it's easier if you start in order. It's a lot easier if you start in order. Don't go out of order, because then you can't really keep track of the factors that you have. So for 18, I'm going to do 1 in 18, 2 times 9, 3 times 6. And then when you get to 6 again, it's 6 times 3, so you already have it. For 42, it would be 1 times 42. You have 2 times 21. You have 3 times 14. A lot of students forget that one. 3 times 14. And then you have 6 times 7. And for 66, you have 1 times 66. 2 times 33. 3 times 22. And 6 times 11. And again, find the biggest number they have in common. And for these three numbers, that number is 6. So your GCF for 42, 18, and 66 is going to be 6. All right, so what happens when you throw in some variables, like the next few examples we have? So when there are variables, you're still going to do the same thing with coefficients, if you do have coefficients, just like we did at the top. But you're also going to find variables that all terms have in common, and you're going to find the one with the smallest power or exponent, and that's the one that you're going to take out. So for example, when we find the GCF of 24x to the fourth, y to the second, z to the seventh, 18x to the second, y to the fourth, and 12x to the third, y, z to the fifth. So immediately notice that everything has x, y, z except for this middle term. So every term has x and y. That's the only variables they have in common. So for 24, 18, and 12, you can do the same listing we did on the top. I'm not going to do that because you know how to do it already. So for 24, 18, and 12, your GCF is going to be 6. So 6 is going to be part of the GCF that you take out. Now, the variables that they have in common, remember, they have to have them in common. The middle term doesn't have z. So we're looking for the smallest x in all three terms and the smallest y in all three terms. We can't really list z because the middle term doesn't have z. So the smallest x we see is x to the second, and the smallest y we see is y. My Cuban's coming out. It's y to the first power. Remember, it's the smallest power that you can see. So now put all three together. You have your GCF of 6. So your GCF for these three expressions or terms is going to be 6. Put down your smallest x, x to the second, and then your y to the first. And that's your GCF. All right, so let's try ST2. Remember, pause, do it on your own, and then play again so that you can see if you did it right. So your GCF for 30, 50, and 5 will be 5. Is the biggest number by which 30, 50, and 5 are all divisible by. Then when you look at compare variables to see if they all have the same variables in common, you notice that first one has x, y, z, second one only has x and y, and the last one has x and y. So we can't really take out z. So find the smallest x, find the smallest y. Smallest x would be x to the third, and the smallest y would be y to the first. So then you add that to the back of the number you just found, the 5. So 5x to the third, y to the first. That's your GCF. Guys, chicken scratch, you know this by now. All right, so for the next example, we have factoring a GCF from a polynomial that has 2 or more terms. So far, all we were doing was factoring monomials. So each one of these was a monomial, or factoring regular numbers, factoring out GCF out of regular numbers. So we're going to throw in adding and subtracting. So now these are polynomials. These could be anything bigger than 2 terms, so 2 or more terms. So for this one, check the numbers. 4x to the second minus 20x minus 16. 4, 20, and 16. The biggest number by which all of those can be divided is the number 4. So we're going to take out a 4. So far the GCF is 4. Notice that the first and the second term have x, but the last one doesn't. So we can really take out the variable. So your GCF for this one is only 4. You can't really take any variables out. But since it does say that you have to write the expression in factor form in the instructions, then what we want is we want to know that number 4, that GCF of 4 that we took out, what do we need to multiply that by? What expression do we need to multiply that 4 by to get the original back? So if you think about it backwards, you've got the 4 outside, right? Now, what would I have to multiply? 4 times what to get my first term of 4x squared? Well, I'm going to need the x squared. What do I need to multiply by? 4 times what to get my next term? 20x, and keep the negative because the signs here, you're pulling out a positive, the signs don't change. So this is negative 5x. So if you were to do 4 times 5x, you would get 20x. And of course, we keep the negative. We keep the next negative. And then you would think, okay, 4 times what to get the last term, which is 16? 4 times 4. So your GCF would just be the number 4, right? When you factor, you write that GCF on the outside, and you figure out what to multiply to get the original back. So this is called the factored form. So this right here is your factored form. So if you were to multiply 4 times that polynomial, you will get your original polynomial. So let's do the same thing with the next example, ST3. So my GCF here, think about what everything is divisible by the biggest number they all have in common. That would be 5, but this one does have variables. They all have x, pull out the smallest x. So your GCF is 5x squared. Now remember, you're writing factors now. So 5x squared multiplied times what? Times 3 terms, 3 certain terms to get the original back. Those are the terms you got to figure out. So 5x squared times 5x squared will give me the first term. If I did distributive property here, I would get that first term. Then I would do distributive property. I got to figure out the second term. That would be minus 3x. Remember, when you're multiplying, you multiply coefficients, but you add exponents. For me to get from x squared to x to the third, I need an x to the first, because I'm supposed to add exponents when I multiply. And then the last term would be 4, but only 4 because 5 already has x squared, and so does 20x squared. So 5x squared times 4 would give me 20x squared. And that's my factored form. So GCF is what they have in common that you pull out at the beginning. Factor form is figuring out what you need to multiply by to get that original back, and it includes your GCF and the factor that you found, however many terms it has to multiply by. That's your factored form. So now let's say we've tried everything we can and we can't really factor the expression. So this is called the prime. When you try everything you can and there's nothing in common and the expression cannot be factored, this is called a prime. So let's check those out. 1 second, guys. I need my coffee. All right, so this one here, 8, 17, 49. Those numbers have nothing in common. There's no GCF for, or no divisible number in common for 8, 17, and 49. 17 is even a prime number, so it can only be divided by 1 and 17, and there's nothing you can do there. If you take a look at the variables, first one has AB, second one has C, and the last one doesn't even have one. There's nothing here, nothing you can take out. This is not factorable because the expressions, the terms have nothing in common. Oh, wait. Not factorable, guys. I don't spell. I do math. I do numbers. Not factorable. There we go. So the response or the answer that you write is just the word prime. That's it. When you check ST4, we're going to have the same problem. 8, 4, 15. We're like, oh, okay, 8 and 4, I can take out 4. But remember, it's in common. So if the last number doesn't have any factors in common with the first two terms, then there's nothing you can do here. You have x, y in the first one for variables. You have y in the second one, but you have only x in the third one. So this one has x, this one has y. Those two already have nothing in common. And the first one has x, y, nothing you can take out. So this is not factorable. This is just prime. It means that there's nothing you can do about it. All right, and the last one is what happens when you're still factoring terms that have coefficients and variables and exponents and all that stuff, but your first term is a negative. So what you do is you do the same thing we did for example 3, but instead of pulling out a GCF that's positive, you pull out a GCF that's negative. Now be careful when you do that, because then that means everything that's inside that you're supposed to multiply by to get the original back is going to change signs, because you're pulling out or factoring out a negative. So this one, for example, the GCF, let's check the GCF first. You have -3, 5, and -4. The coefficients have nothing in common. There's no common divisor for -3, 5, and -4. So let's check the variables. You have x, y, z. You have x, y, z, but you have x, y. So no z. You can take out z. Smallest x is x to the first, and smallest y is y to the second. So your GCF is x, y to the second, but because your first term starts with a negative, take out that negative. We don't want the second factor to start with a negative. So my GCF is -xy squared. Now I gotta figure out, to write this in factored form, what I need for each term to be, so that when I multiply, when I distribute that -xy squared, I get the original back. So from this first term to get here, we're gonna need a 3, an x to the third, because this is, an x to the second, because this is an x, and I need an x to the third. The y to the second is already there, and I'm gonna need a z to the third. So I'm gonna need a 3x squared, so that when I multiply x times x squared, I get x to the third. And I'm gonna need the entire z to the third. I don't have any z's as common factors as GCF, so I'm gonna need z to the third. Then remember, you're multiplying negative times what? To get positive, that's going to be negative times negative. This is what I was talking about before. If you pull out a negative, all of your terms inside the parentheses will change signs from the original. So it'll be the opposite. So this first term will have the opposite sign. The second term will have the opposite sign, and the last term will have the opposite sign. Then to get from -xy squared to positive 5, x to the fourth, y to the third, z to the fifth, I'm going to need the 5, the -5. So it'll be negative times negative to get positive. I'm going to need an x to the third because I want to get all the way to x to the fourth. From y squared to y to the third, I'm going to need another y. And I'm going to need the entire z to the fifth. And let me see if I left enough room for this. Let's see. It might fit. So negative times what to get a negative? That's a positive. So you need the 4, positive 4. You have x, y squared. You want x, y to the fourth. So you're missing 2 of the y. So y squared times y squared will give you that y to the fourth that you're missing. And that's your entire factored form. That's your answer for that one. And then try ST5 on your own. Remember, pause, do it on your own on your own paper, and then play to see if you got the right thing. But the GCF on this one, if you look at the numbers carefully, you're gonna have a 2 in common. You're gonna have an x to the third, and you're gonna have a y to the second. And of course, for notes, I use the same variables. You could have any variables. You could use MP. So when you do the practice, you could have anything. Now notice your first term is negative. So pull out that negative as well. So my GCF is negative 2, x to the third, y to the second. What do I need to multiply by to get all 3 original terms back? Well, I'm going to need a 6 here. Negative 2 times 6 will get me to negative 12. X to the third times x to the second will get me to x to the fifth. And y to the second, I already have it. So y to the second is just going to stay. I don't need anything else here. Then I'm going to have negative 2 times what to get positive 6? That's going to be negative 3. From x to the third to x to the fourth, I'm missing an x. From y to the second to y to the fourth, I'm missing a y to the second. So when I multiply, I actually add the exponents, I'm going to end up with a y to the fourth. The last one is negative 2 times what? To get negative 8, that's going to be a positive. Positive 4. Then x to the third. X to the third is already there. I don't need to put any x's down. Y to the second. To get all the way to y to the fifth, I'm going to have to multiply times y to the third. I can add the 2 exponents and end up with y to the fifth. So this is your expression in factored form. All right, guys, this is your prep. So when we do the next lesson, which is actually the factoring lesson. All right, so practice, practice, practice. That's what's going to help you understand this stuff. Have a great day. See you next time.